right, we're going to take a look at some of the fundamental terms in geometry. In general, mathematics is very precise. Words have specific meaning. Not only do the words have specific meaning, but the way we draw, the way we label them, and the way we use notation. That's also very, very important, and we're going to take a look at all of those things today. All right, so the first term we want to look at is that of point. It's one of three undefined terms, and by undefined we simply mean that we give examples of and descriptions of the term, but there is no real definition. We will then use those terms to define other terms in mathematics. All right, so points, lines, and planes are going to be our three undefined terms. The first term, point. A point has no size, okay, and it has no dimension. It's simply a location in space. Now, of course, here we draw a dot to represent a point, and we can see that, therefore it has dimension. But that's the only thing that we can do. So our model is not exact. If we could model a point exactly, it would have no dimension and no size, but then we couldn't see it. So anyway, a point is a location in space, and points are named using uppercase, print, non-script letters. Very, very important. Okay? Uppercase print letters. A line is our second undefined term. A line is made up of an infinite number of points that go on without end in both directions. Okay, so an infinite number of points. A line has one dimension, length. Point, no dimension, line, one dimension. A line can be named with a lowercase script letter or by any 2 points on the line. Okay, so here we have line AB with the line over it, and we could also name it with a lowercase l. So let me just draw a picture here. If we have a line, let's say I have points here, A, B, and it has an infinite number of points, C. I could name that line, line AB, with a line over it. I could name it BA with a line over it, AC with a line over it, so on and so forth. What I would not do is A, B, C with a line over it. No. Whoops, I made a G there, but you get the picture. 2 points, name a line. Okay? And also lines could be named with lowercase script letters, L, so on and so forth. Okay. 2 parts of a line. A ray is a part of a line, and a line segment is a part of a line. Whoops, let's move this up. And I made a miss here. Okay. So part of a line, a ray, and a line segment. A ray has a definite starting point, and then it extends in one direction without end. So this would be point A, and when we name it with the end point and one other point that it goes through. So a ray is named using the end point, then any other point on the ray. Okay? And that's our symbol, an arrow. A line segment. A line segment is also part of a line, and it has 2 endpoints and all the points between them. A, B. This would be line segment AB, and it is named using the endpoints. Okay? The order in which we name line segments does not matter. This is AB or, equally fine, BA. The order in which we name a line, AB or BA. The order in which we name a ray is very important. It always must start with the end point and then whatever other point it goes through. All right. Two terms that are new, but I think fairly simple terms to understand. Collinear, if you were co-captains, together you would be captains of a team. So co meaning together, points that are together on the same line, that lie on the same line. Non-collinear, they do not lie on the same line. Okay? All right. Now, let's go back a second. We had a point with no dimension, a line with one dimension, and our third undefined term is a plane, and it is a flat surface that extends without end in all directions. It has two dimensions, length and width. A plane can be named by three non-collinear points, or a single uppercase script letter. Notice that a point was an uppercase non-script letter, and now a plane is an uppercase script letter. Okay, a parallelogram is used to model a plane. So let's just take a look here. Here would be a parallelogram, and I might name this plane, oh, I don't know, how about R, and it would be script. I also could name this plane A, B, C. So those are two ways I could name the plane, plane A, B, C, plane A, B, C, or plane, and now I'd have to make that a script R. Okay. Collinear meant on the same line. Coplanar means on the same plane. Non-collinear means not on the same line. Non-coplanar, not on the same plane. All right. So we have no dimension is a point, one dimension is a line, two dimensions is a plane. What about three dimensions? What name should we give to three dimensions? Points, lines, planes, and I left it blank. If we were in class, everybody would be yelling out different names, but we are not. Giving you some time to think. S, P, A, C, E. Space. Boundless, three-dimensional set of all points. All right. Now let's look at some relationships between these things. We have lines, and now we have the term parallel lines. Well, sometimes in mathematics, we don't completely give you all the facts. Why? Because you're not ready for them. So most of you simply know parallel lines as lines that are the same distance apart and lines that do not intersect. Well, if that's the case, what words do I want in here? Lines that are always the same distance apart. I want some words there. The part that we didn't tell you, parallel lines are lines in the same plane. In the same plane. Lines that are coplanar. I don't care which way we define it, which way we state it, it means the same thing. So lines that are coplanar, that are always the same distance apart, or lines in the same plane that are always the same distance apart, are parallel lines. They do not intersect. The next term, skew lines. They also do not intersect. Well, if parallel lines are in the same plane, then skew lines must be in different planes. So lines that are not in the same plane. And let's take a look. Let's say I had, a box. Not a very neat box here. This horizontal edge and this back edge would never intersect. It appears here that they're intersecting, but they are not. The reason it appears is because I'm trying to draw 3 dimensions on a flat 2-dimensional surface. But this, if you had a Kleenex box, for example, this bottom edge and this here, this is horizontal, this is vertical. This is in the front plane, this is in a side plane. These are called skew lines and they do not intersect. Okay, and I'll show you some examples in class. What is an intersection? Intersection is the set of all points that are in both figures. Okay, so here I have 2 lines. Their intersection is 1 point. This point is in this or on this line, and it is also on that line. This 1 point is in both figures. Okay. The next term, concurrent. Well, that's an important term. If I had this situation, I could say that these 3 lines intersect. If I have this situation, I could say that these 3 lines intersect. Both pictures show intersecting lines. This picture, however, shows concurrent lines because all 3 intersect at 1 point. So this is an example of concurrent. Concurrent lines. Okay? This is not. Good. All right. Locus is a nice little point, or a nice little term, not one that you necessarily need to know. It's just used frequently in definitions. And locus simply means the set of points, set of all points that satisfy a particular condition. So the locus of all points equidistant from a given point called the center. That is a definition here of circle. So imagine I have a point, and I go some distance out, and I go that same distance out, and I go that same distance. And I keep doing that, the same distance away from that point. And I connect this infinite number of points that are equidistant from that fixed point. That is a circle. Sphere, the locus of all points equidistant from a given point called the center. Well, now a sphere and a circle cannot have the same definition. So what is the difference? What do I want in my blank spot? Well, a circle is a plane figure, and a sphere is a figure that exists in space. So a circle is the locus of all points in a plane, equidistant from a given point. And a sphere is the locus of all points in space, equidistant from a given point called the center.